This is our first video, and in this video we're going to take you through the basics of Arduino so that you can understand what is an Arduino, how does it work, and what kind of projects can you use it for your studies or for whatever purposes you might decide to use the Arduino board. So let's get started. So first thing first, what is Arduino or what is an Arduino? Well, this is a low-cost, flexible, and easy-to-use programmable open-source microcontroller. It's a bit lengthy, but in short, what we are trying to say is it's a small computer which you can program to do what you want and connect it to various devices, be they input or output devices, to do what you want or what you need at that moment. So this is our Arduino board. So for the purposes of this tutorial, we're going to be focusing on the Arduino Uno. So this is the layout of the board, how it typically looks like, different components it has. So don't worry, we're going to explain the major components one by one detail. So first is the USB port. Our Arduino is a USB-A type. USB, you might recognize this from your printer. Most printers still today, they still use this form of USB. So that's the one you can use to connect your Arduino to your computer so that you can communicate with it. So depending on the model of the Arduino board you are using, you might see a different port there. Don't worry, they still work the same. Others have USB B type, others even have USB C type, but the purpose is the same, is for you to be able to connect to your computer so you can upload your code there. So next is the power jack, the power port. So by standard, our Arduino uses 5 volts for power supply. This is not a fixed source of power. You can go as little as 3.3 and you can still power it on, but depending on the amount of peripherals you are connected to the Arduino, it might not work properly. As you will realize, you can even go up to 20 volts input, but I wouldn't recommend it. At least try to stay within the range 5 to 9 volts. There you are safe and you have optimum performance from your Arduino. Next we have the microcontroller area. You will see this is the heart of the controller, just like your PC or your Mac or whatever brand of machine you are using. There is a microcontroller chip inside it, or you might call it a microprocessor. They are one and the same thing. These are the ones which do all the work, from displaying videos like how you are watching this tutorial. Is the processor or the microcontroller that's doing that. So your Arduino also has one. You might realize it's got a very little flash memory, 3.32 KB, 2 KB RAM. It's more than sufficient for what you're going to be doing. This is not a full-fledged computer. It's just a miniature version for you to experiment and play around with. But you'll be surprised to find that you can actually carry out really complex projects using such a small device. So next, we'll go to analog pins. So you will realize on Arduino that there are analog pins there, labeled A0 to A5, or analog then 0, 5, depending on the board which you have. From the different manufacturers, they label differently, but the positions are always the same and the functionality is the same. So what these ports do, they allow you to send analog signals from different sensors you might be using. For example, a fire sensor, it will send a particular voltage depending on its reading. It cannot tell the exact degrees it's measuring, but it has what shall we call, it has mathematical formulas that it uses, that a specific voltage output corresponds to a specific reading in degrees Celsius. These you might know, you don't really have to know by the back of your head, because most of these sensors, they have libraries which you use, and there are plenty of explanations in those libraries and example codes from you for you to learn. But for now, I just want you to know that these analog pins, input pins, they are for input. So one thing you might want to know early on and discover this later on, in as much as they are labeled analog input pins, you will realize that you can actually use them as output pins at the same time. So when you start writing code, maybe in video 2 or 3, you will realize that you can actually tell your controller, your Arduino microcontroller, by code that this specific port, I want to use it for output. And since it's an analog port, you will be using analog outputs, which are from 0 to 255. And this also corresponds to the voltage output between 0 to 5 volts. So in as much as they are input, you can actually decide to use them as analog and they will still work. We will talk further about this as we go on with our tutorials on where you can use such a setup in what scenarios you might want. For example, I'll just give a quick one. Let's say our LED. You can either turn it on and off. So when you turn it on, it goes to full brightness. But maybe in this case, you don't want the full brightness. You just want a low dimmed light. That's when you can use analog output. So if 255 was the full brightness of the LED, you obviously know when you write an output of 150, the light will be a bit dim. So that's one area where you can decide to use that. So next, digital pins. I'm sure by now you can guess how they function. They are just the same as our analog pins, but these ones you will notice they are just written digital pins. They don't specify input or output. So you have to know that when you want to use them as either input or output, you have to declare this when you are writing your code. That's when you tell them. So their output is just on, their state is on or off. You don't write a specific value like the analog ones. But these ones, they're a bit more sophisticated in that there are some sensors which can provide a more detailed output. For example, let's say we might be using a sensor that measures the amount of gases within the air. It may tell you exactly how many parts of a different gas are in there. When you wouldn't be able to do this with analog pins, but the digital one, they can give a specific value, or maybe even send a string of characters through those pins. It will work. And the other good thing about these pins is that they can actually act as a power source on the components you are connected to. The simple one is an LED. You can just connect your LED to the ground pin, and then the positive side you connect it to your digital pin. So when you turn to digital on your pin, it powers on the LED automatically. So it can also act as a power source. Next, there is a reset switch right there at the top right corner of your board. So as the name suggests, it's used to reset your board. So you have to take note, this reset does not, let's say, reset in the sense that maybe when you reset your cell phone, it's more like you're wiping out the data on the phone, clearing everything, then it reboots as a new phone again. But in this sense, it's more like restarting your board. Just turns off your board, then starts running again. Right? So sometimes they have a malfunction or someone disturbs the physical operations of the board, just click it, turns off, then it starts running again. Or maybe you're debugging your code or testing it. You might find it very useful. Going on, we have a crystal oscillator. Well, I won't explain much about this because you won't use it directly most of the time. It will be working in the background. You won't know, you won't manipulate it directly. So basically, this is just more like a clock. It's a crystal oscillator which is used by your board for time operation. So the moment your board turns on, it also starts running. So the board can use it to perform calculations like how long has it been running. So it has its own internal clock. If you specify a certain function to run for maybe 3 seconds, this is where it comes in. Is how it can actually calculate time. So you will find out it's pretty fast for a small computer. I mean, 16 million cycles per second, that's 16 million operations it can perform in a single second. So you realize it's pretty fast. You can do a lot of things with this board. So next, there's the USB chip, interface chip. So just like the crystal oscillator, this one you won't directly use it or manipulate it, but it will be working most of the time without you even realizing it. It's the one which allows you to plug in your physical USB cable and communicate with your computer. Without it, you just plug it, it turns on, doesn't even understand anything. This is what allows you to upload code to your board via USB cable. So last but not least, you have the TX RX LED. These are built-in LEDs. They are just there to signal to you as a visual signal whether there are some operations going on with your board, whether it's sending or receiving data somewhere. So you will notice that on the digital pins, pin 0 and 1, they are labeled RX and TX. Those are the transmission and receiving ports. So whenever you are sending data through those ports or receiving data through those ports, your LEDs will be blinking accordingly. So the faster the data is coming or the more data is coming, the more your LED blink, the faster they blink. If this data is coming in little by little, slowly, you actually see the LEDs blinking slowly here and there in accordance. So I hope you enjoyed our first tutorial on understanding our Arduino. So our next video will take you through the process of how you can download, install Arduino IDE on your machine, and how you can set up your Arduino and start programming. Thank you.